Okay, so we're given a bunch of graphs up above, and they say in each case state the number of distinct zeros and the possible multiplicities of each zero. So we're looking at what different multiplicities look like on a curve. Curve I, we have a root or a zero there, and we have a zero here. So two distinct zeros, first of all. Now their multiplicities are next. Here what we see is that the curve comes down, touches the axis, but then turns away. This is called a tangency, or sometimes they call it a kiss. That happens when your multiplicity is 2 or 4 or 6 or 8, any even number like that. Those are the possible multiplicities for this point, and you can't really tell just by looking at it unless they give you more information about the curve. The second one is sometimes called an inflection point, is where the curve comes down, it turns like it's about to double back, and then decides, no, I'm going to go through. You get like an S-bend where it crosses the axis. And inflection points, or S-bends, happen when your multiplicity is either 3 or 5 or 7, any odd number other than 1. So those are the multiplicities there. For plot number 2, there's an x-intercept, or a root or a zero. There's another in the middle of that, I suppose. It's very flat, but I'm guessing there's just one touch of the x-axis. And here's a third. So here we've seen this. This is a tangency, where it comes in, just barely touches the axis, and then curves away. That's got to mean multiplicity 2 or 4 or 6, etc. These are the simplest kind. When a curve simply punches through the x-axis like it doesn't even notice it's there, without any change in its curvature, without doubling back or anything, those are multiplicity 1. So these two, where the curve just goes through the x-axis without any change, any kind of blip in its behavior, those are definitely multiplicity 1. Let's see about these now. X-intercept, I'm going to change colors, make this a little clearer. There's a root, there's a root, there's a root. So, comes up, touches, turns away. That could be multiplicity 2 or 4 or 6, etc. Same thing here. This is another one that we call a tangency, some kind of even number. And this one is a straight cross without any kind of curvature, so multiplicity 1. And for plot number 4, 3 distinct roots. And this one's got to be multiplicity 1 because it just crosses through. Here again it just crosses through, multiplicity 1. And this is an inflection point. It comes in, curves like it might turn away, like it might go back into the negatives, but then it decides, no, I will cross through. These are multiplicity 3 or 5 or 7, etc. Now, in which of these graphs could we have a polynomial function of degree 8? Well, let's look at the multiplicities we have. This one could be 2 or 4 or 6 or 8. This one could be 3 or 5 or 7. There isn't really any way that any pair of these numbers can add up to 8. One of them's odd and the other one is even, so we can't get an even sum out of that. That one's out. Plot number 2, we have multiplicity 1 plus 1 plus, if we took 6 here, that would give us a total of 8 roots, and that would make this a curve of degree 8. So, yes, that's a candidate. Here, we can't get a total of 8 here. We have even number plus 1. There's no way we can get 8 from that total, so that's a no. And 1 plus 1 is an even number. Add that to an odd number, and no, we can't get 8. So the only chance for question B is to use plot number 2. This could be a curve of degree 8. And finally, in which of the graphs is the leading coefficient positive? Well, you don't even have to look at the roots to see this. There are two ways that these curves can behave, and they're pretty easy to remember. An odd curve with a positive leading coefficient will do this. It'll go from the negatives up into the positives. Now along the way, it may have a couple of bumps. It may have a whole lot of bumps. But in the end, it will always go from negative in the bottom left to positive in the bottom right. So x cubed will do this. X to the fifth will do this. So will x to the seventh, and anything else with an odd leading coefficient. If it has a negative leading coefficient, it'll go the other way. It'll start in the top left and go downhill. That's things like minus x cubed, minus x to the fifth, minus x to the seventh, and so on. For the evens, you get U-shapes generally. If you have positive x squared, or positive x to the fourth, or positive x to the sixth, etc., you'll get a U-shape that'll go positive on both ends. It may have a bump in the middle, like a quartic. It may have a whole bunch of bumps. But on the two ends, as x becomes very big, it'll go into the positives. If it's negative x squared, or negative x to the fourth, negative x to the sixth, etc., those will be inverted U-shapes. They'll go into the negatives on both ends. So just looking at the end behavior, you can tell instantly what the degree of a function can or can't be. This one goes from positive down into the negative. What do you think? What does that tell us about the degree and the coefficient? It starts high and goes low. This has to have a negative odd characteristic to it. It's got to be something like minus x to the 5, minus x to the 7, minus x to the 9. Something like that to account for it going into the negatives. Plot number 2 starts negative and ends up negative. The fact that these are both going in the same direction means that it's even, and the fact that it goes towards the negative means it's minus an even power. It's minus x to the 8, or minus x to the 6, minus x to the 10, something like that. Plot number 3 starts in the negatives and goes to the positives. That tells me it's odd. And the fact that it goes negative to positive, or that it ends up in the positives, means it's got to be odd with a positive leading coefficient. This could be something like positive x to the fifth, or positive x to the ninth. And finally, plot number 4, well, that also starts in the negatives and then goes to the positives. So again, it's odd because these are opposites. And again, it's positive because when x gets very high, it goes into the positives. So this again is something like x to the 9th or x to the 11th, something with a positive out front.